Okay. So let's see. Not a whole lot's happening, in the coming weeks. I mean, we're going to continue to move on. We are actually going to be finishing up in the next couple of weeks our statistics unit. We're going to be talking about correlation today, probably on Monday as well. Get into linear regression. Then we'll get into the chi-squared. We have our next exam just under 2 weeks from today. Next quiz on Tuesday. Okay, so if you have any questions or you need some help, please let me know. Okay, I am available. All right, what do we got here? Focus activity number 5. I want to find the mean, mode, and median of the following data set. Okay, and then I want to use technology to find the standard deviation. Okay, now since we're going to go ahead and find the standard deviation using technology anyway, do we want to go ahead and just use technology for the rest of it, or is there anybody who'd like to do that by hand? No? No, calculator's fine? Okay. Now, probably what's the one we don't need to worry about by hand? Or by technology, I should say. What's the one that we can easily do by hand with no work? Okay, so which number shows up the most? I'd say 15. So the mode, we can just go ahead and say 15. Boom. Okay. So let's go ahead and say I want to take this set of data. Okay. We're going to plug it in the calculator. Come on over here. I'm just going to go ahead and do this because it's probably going to be way faster. So I'm going to go to my home screen. Now, I always click number 1, and it brings up this set over here. But if you click down here, that actually shows an icon of the spreadsheets. Okay, it'll take you straight to it. Of course, there's always going to be different ways to do things. We've only got the one set of data. I'm just going to call it the X's. All right, so I think the first one was 13. Is that right? Okay, I don't have that copy in front of me, so someone shout out the numbers to me. 12. Okay, so there's only 10. Okay, so I've got my data in. Where do I go if I want to go ahead and get the standard deviation, see the mean, also get all those values related to the box plot? Menu. Statistics. Stat calculations. Definitely one variable. We've only got one set. Okay. Click OK past this box. Now, it'll probably give you something in that first tab. Just go ahead and delete that. Choose the heading you put in. Now, frequency list, that is the frequency list, basically. Okay, you just didn't generate the number of elements that we have in this particular set. Even if you go ahead and delete it, it's going to pop back anyway. Looks like all my information is showing up in column C, and here we go. So we do have 10 elements, and we're actually down near the bottom. So we also wanted the median, which turns out to be 15. Okay, so we have that one. What should I be getting for the mean? I got 14.8. And I keep forgetting, which one do I want, S of X or sigma X? Sigma X is the one I want for standard deviation. Okay, so let's say that's 1.78. Let's say we want to round it to 3 sig figs. So 1.78. What was the mean? 14.8. And the median was 15 as well. There we go. Okay, any questions? How are we doing? Yes, ma'am.
I put mine in as okay. I put it in as 2 columns and just put the frequency in, and it gave me whole numbers on all of for the mean and for the student.
Oh, so you kind of put it in as a frequency table?
Mm-hmm.
Interesting. I would imagine it'd be giving you the same thing, because there you're just telling me the number of elements, and here we actually put in the actual elements themselves. Let me look at that. I don't know why it should be doing that. I would imagine it would give you the same thing.
It's possible that I did it.
Really? Let me look into that. Let me look into that, and I'll get back to you. Okay, so any other questions? Mhm. Ethan, did you do that too? Oh, okay. But I will look into that. I'll see why that is. I honestly don't have an answer off the top of my head. Okay, so I will look into that. Okay, good. Let's see. So we got all that done. Let's get back to correlation. Okay. All right, you ready for a good laugh? Well, of course you are. I mean, you're in math studies. You know, I'm a very funny man. But your teacher's somewhat of a silly goose, made a little mistake. I started teaching the correct lesson yesterday. We are on correlation, but I just put out the wrong notes. Thank you, Jacob. Okay. Now, everything we've done so far is correct. That's why I had the about the 2-second thought yesterday. You know, that's weird because normally students have a copy of this that they write on, but that's why. I mean, you just wrote it out. That's fine. You have the correct notes now. So the notes you picked up yesterday, that's for the next lesson. Okay. I just had the wrong notes out. It's still the correct material. Okay. So there's no big, huge mix-up. Okay. All right. So we started talking yesterday about something called Pearson's correlation coefficient. The variable used is R. Okay, it's a very large formula made up of 3 different parts. S sub xy was the covariance. S sub x was the standard deviation for your x's. S sub y was the standard deviation for your y's. And this was how they were related to each other when you were going to find it. Okay, so we're talking scatter plots, right? So typically when you think scatter plots, you're going to think of graphs like this. Okay, so what is that numerical value telling me? If I don't have the graph in front of me, what is it helping me to visualize? Now, what is the value of R, the correlation coefficient, telling me? So if I don't have the scatter plot in front of me, what is that value trying to help me picture in my mind as far as the data points? Okay, so I think I know what you're talking about. So what's another way we could describe that? What can we say about the points? How? Okay, I like that word. How concentrated they are, or if they are what? If they're closer or further apart. That's exactly right. That's what it's helping me to picture. Now we have 2 ways of looking at this, because you can either have a positive or a negative trend depending on how your points fall. But we talked about this yesterday. Whether it's positive or negative, you're going to have a numerical value between 0 and 1 being positive, between 0 and -1 for the negative correlations. So on either side, the closer that value is to 0, the weaker, the further apart those data points should be in your graph. Okay, and conversely, the closer I get to 1 or even -1, the stronger, okay, or the more tightly packed those data points are going to be. I like the word Naya used, the more concentrated they're going to be. All right. So we worked an example by hand. Okay. Here is the correct set of notes. Okay. So a scatter diagram, we've been talking about those. Really, I don't want to read this, word for word, because that's going to get boring again, but you can definitely go ahead and take a look at it. I did mention this yesterday. The form depends on the general shape of the scatter plot. Now, the scatter plot can have any number of models, as I mentioned, but in here, we're just going to stick with linear. Okay, and typically we're going to go ahead and say slope-intercept, y equals mx plus b. All right. Now, the strength of the relationship is given to us in this diagram. This is what IB follows. So we would go ahead and say you have a strong relationship, okay, if it falls between 0.75 or 1. Okay, moderate between 0.5 and 0.75, weak 0.25 and 0.5, and then basically no relationship at all if it's between 0 and 0.25. And you'll notice, looking at those class intervals, one is included while the other is not. So in case you do get one of the upper and the lowers, it should be okay. Now here's something, outliers. In bivariate, 2 sets, that's all that means. When you see the word bivariate, that means we're comparing 2 sets of data. Okay. It's important to make note of any outliers that may occur. These generally appear as isolated points away from the main body of the data. So let's say you're already thinking about your IA, right? Okay, you probably haven't started writing it yet. That's perfectly fine. We're going to talk about the outline in a couple of weeks. That's coming up on the 30th. But at least be thinking about, the idea. More important now, how to collect the data. Well, if your IA topic has you comparing two different quantities, a scatter plot may be a really good way to go ahead and not only visually show that, but also give you a way to analyze and further interpret what you're looking at. So let's say you collect data, but you have an outlier. Okay, you have one piece of data that's radically different from the rest. Should you include it or should you discard it? What would you guys think? I like the way Ella said that. Say it again, ma'am. I would still include it because even though it may be for whatever reason radically different than the rest of the data you collected, it is still part of your data. It still plays a role. So even if it's an outlier, I would absolutely go ahead and say yes, include it. Now, outliers should be investigated. Okay, got that. Now, causation. When you're talking about correlation, okay, you've probably heard this phrase before. Correlation does not imply causation. So what is causation? What am I meaning when I say that? Yeah, okay, one thing, okay, directly affects another item, okay? So correlation between two variables does not necessarily mean that one variable causes the other. Consider this example. The shoe size and reading levels of children from elementary through high school were studied, and a strong positive correlation existed between the variables. Okay, does this mean that large feet make someone a better reader? Absolutely not. That's exactly right. And that's the thing. That's part of what you're going to have to comment on in your IA. A lot of times people are going to choose items that are absolutely going to have some kind of relationship with each other. But just because you get a strong relationship, a high value of R, it doesn't necessarily mean that there is causation there. So you just want to be careful about that. It's like if I were to say, all of my math students get amazing grades and they have a lot of mathematical knowledge, well, is that directly attributed to the amazing math teacher that you have? Probably, but I can't say for sure. Okay, because everybody learns differently. Everybody has their own habits. I mean, I'm just one man and I do what I can. Notice it's a little quiet when I say things like that. I'll just keep going. Okay, here we go. Thank you, Joe. I appreciate that. Yeah. All right. All right, so when variables are related so that if one is changed, the other changes, we can say there is a causal relationship between the variables. And once again, here are the formulas. So S sub xy, that's the covariance, and then the other two represent the standard deviation or the measure of spread between your two sets of data that you are comparing. Okay, well, let's get right to an example. All right. So here are all my formulas. Here's the definitions. Now, we did one by hand yesterday, right? And there was a lot of information. This is one that's very likely what's to happen. I mean, just look at the data you're comparing. We've got these 8 values of x compared against these 8 values of y. Okay, so all of this has already been worked out and filled in for you. So you'll notice very easy to go ahead and make a mistake, especially with a lot of those decimal values. Okay, so the reason I had this ready for you to go, again, on the paper exams, will you be required to do this? No, you're going to be using technology, but I do want to go ahead and throw this out there. If you decide in your internal assessment that the Pearson's correlation coefficient is going to be a strategy that's going to be very useful to you. What was that? I thought I heard something. What's that, Ella? Oh, somebody's following up. Can I answer it? Ella's the one. No. Okay. You gave him my social security number. What was that again? Wasn't it some car company? Your car insurance, yeah. 15% could save, or 15 minutes could save you 15% or more. Okay. Ask the caveman. All right. All right, where was I? Oh, yeah, we're talking about data. Okay. So if you decide you want to go ahead and use one of these strategies on your IA, you absolutely want to go ahead and create a table like this. Okay. The whole idea behind the internal assessment, and I always tell people to do this, pretend that whoever is reading your paper has absolutely no background in mathematics at all. They don't know any of the strategies that you're about to explain. So you want to make sure to walk the reader through exactly what you're doing. I mean, you can definitely go ahead and use the technology to confirm your answer, but you want to show him or her exactly how you obtained that result. Okay. Any questions on that? I always think that's a great idea. Okay, always. All right, well, let's go ahead and do this. Let's figure out what the correlation coefficient is based on the data that's already provided, and then I'm going to go ahead and show you how to do this by hand. So in order to do it like this without the technology, well, we got to find these three values here. So you'll notice for the covariance, I need the sum of the product of the differences of the elements and its mean. So first, we got to know what the mean is. Okay. So how about the left side of the classroom? I want you guys to go ahead and find me the mean of the x's. Right side of the classroom, I want you guys to find me the mean of the y's. Okay, so mean of the x's, mean of the y's. Okay. And then we'll come back and we'll see. I pre-calculated those before myself. Hopefully our numbers are going to match up. But as soon as somebody on one side has that particular value, go ahead and let me know. Okay. And I went ahead and wrote my x mean to 3 decimal places, and then I got 2 decimal places on my y mean. What'd you get, John Henry? I got 3.875 for x's mean. 3.875. Jacob, is that what you got? Nice. Okay, so who on the other side of the classroom? I'm looking for y's mean. You know, actually, I used to have that. At the bottom of my taskbar on my computer, I did have, this was several years ago, I had a laugh track where I felt if I told a funny joke but didn't get the response I was looking for, I could click it and I would hear a little laughter. Or even if I thought the joke was bad, I did have a cricket sound on there. But unfortunately, years ago, they came in and they replaced the entire computer, brand new towers, computers, all that. And I just have not, I've been lazy, haven't put it back on there. Because, I mean, you know, people laugh anyway, right? Okay. All right. Elizabeth, you look like you're so amused right now. All right, who's got y's mean? What'd you get, Lizzie? 3.25 is exactly what I got. Perfect. Okay. So you can go ahead and start to check some of this. If I take the values of x and subtract its mean, take the values of y, subtract its mean, you'll go ahead and notice, hopefully, that these values are accurate. Okay. Well, in order to use these formulas, I need the sum of the product of those differences. So I'm going to need this guy right here. I need to know the sum of those decimal values. Okay. I also need to know the sum of the squared differences for x's standard deviation, and I need to know the sum of the squared differences for y's standard deviation. Okay. That is a horrible arrow, so I'm going to go ahead and erase it. There we go. All right. So everybody be working on these. I need the sum total of those bottom 3 rows. Okay. So as soon as anybody believes they have them, just go ahead and let me know. And I just kept the decimals. Okay. I didn't worry about rounding, because if you round in the middle of your process, it will affect your final answer. Okay, 15.5 for the sum of the square differences for the y's. That is what I got. Okay. All I need is 2 more. Okay. And let me go ahead and move over here, because I have the same table, and I actually have my formulas. So we got a 15.5 right there. Has anybody got the sum of the product of the differences? The third to last row. $13.25015. Is that what you got? Perfect. Okay. 13.25. That is a 525015. Perfect. And now all I need is that second to last row, the sum of the square differences for the x's. Yes, I just kept it as 89 at the very end, but that's exactly what I got. 22.87. 22.87489. Perfect. Okay. So you can already tell that even if you start with data that looks relatively simple, I mean, the table itself, doing it by hand, could be somewhat tedious. And there are plenty of places where you could make a mistake. Okay, which is again why I'm going to encourage you to focus on technology, but there are times when, yeah, you got to show me how to do this. Okay, so this right here, S sub xy, remember that's the covariance. So according to this, I need the sum of the product of those differences. That was given to me as 13.25015. Now, what am I going to divide that by? 8. Okay. Now remember, there's only 8 elements in the x set. There's only 8 elements in the y set. We don't count them all together. We're comparing 8 different pairs. Okay, so I'm about to go to the calculator for him in just a second. Now, standard deviation on the x's, I'm going to have this radical. What do we get for the sum of the square differences for the x's? 22.87489. Again, I'm going to divide that by, put in 8. Okay. And then for this right here, S sub y, again, just plugging in the formula. Okay, so I'm going to have 15.5 divided by 8. Okay. Now, once I have exactly what I need to input into the calculator, I'm just going to go ahead and let it take over from there. Okay, now there's a number of different ways you could do this, but I'm going to evaluate each of these individually, and then I'm going to go ahead and have them interact with each other. So let me show you what I mean. Let me come back over here. Let me go back home, calculate. Okay, so the first thing is I need control divide 13.25015. I'm going to divide that by 8. Okay, so I have a value for the covariance. Okay, next I'm going to move on to the standard deviation for the x's. Okay, so that sum was 22.87489. 22.87489. Okay, divided by 8 once again. Okay, so there's the standard deviation for the x's. Okay, one more time. Okay, now I'm going to take, what was it, 15.5 divided by 8? Okay, there we go. Now, in order to go ahead and find Pearson's correlation coefficient, that value of R, which describes what I'm going to see on the scatter plot, whether they're very close together or whether they're very far apart, I'm going to go ahead and take S sub xy. Okay, I'm going to divide it by, and I'm just going to write it as a product of the two. So I'm going to put these others in parentheses. So there's the standard deviation for the x's times, oops, was too far, the standard deviation for the y's. Okay, S sub xy divided by S sub x times S sub y. So when I push enter, looks like I'm getting about 0.70. Okay, which according to the intervals we were just looking at, I would say it's a moderate, okay, moderate level. It's getting close to strong. It's very close to strong, okay, but not quite enough according to the essential we were given, that class interval. So now, that's all well and good, but we're not going to be doing them by hand a whole lot. Again, I think it's important that you see how it's done. Now let's take this information, plug it in the calculator, and let's see if it gives me the same thing. So think about how much work you'd have to do creating that table, and then what we just did here, finding this final answer, this 0.70. Okay, so now go back to your home screen. Now I'm going to go ahead and get rid of the previous example that we had. Do you want to save that? No. Okay, so I'm going to go to new document, just like we always do, list and spreadsheets. So I've got to input the data, the two different sets. So X was 1. Oops. Might help if I go ahead and type in the correct one first, sorry. Titles, X, Y, there we go. Now let's type in the 1. Then what do we got? 5, 6, 6, 5, 6, 6, 2, 3, 4, 4. 2, 3, 4, 4. Okay. And then I'm just going to hit Control 7, takes me right back up to the top. And then I want to put in the corresponding Y values. 2, 4, 5, 3, 1, 2. And what do we end up with? 5, 4. Okay. And especially if you're dealing with a large amount of data, I always think it's a good idea. Take a few seconds, just go back through and make sure that all your data is input correctly. Remember, because your analysis and your conclusions are going to be based on this, right? Okay. So now, once I've got the data in, does anybody need help doing that? Okay. What we're going to do, we go to Menu. Okay. Where do you think I'm going to go from here? I'm going to go to Statistics, Stat Calculations. So what will I choose this time? This is two variable. We are actually comparing two different sets of data. Okay, so I'm going to choose two variable. All right, and this is where we normally go back and we make sure that the headings we typed in are going to be found there. So for the X list, I chose X. Okay, for the Y list, chose Y. Okay, don't worry about the frequency list. That's going to be there no matter what. Looks like all my information is going to show up in column D, and I'm going to click OK. All right, and here we go. I mean, just look at some of the values. What was the standard deviation for the X's? Did we get it to be 1.69? Yeah, if we look back at our information, okay. Let's see, there's the mean for the X's. There's the mean for the Y's, exactly what we came up with. There's the 1.39, we got that previously. Now, what did we get for R, the correlation coefficient? We got 0.70, right? Okay. Well, if I keep going down here, that's what we got. Calculating it both by hand and just using the technology. Okay. So which way is definitely faster? Definitely the calculator. The technology is way better. Okay. All right. But, you know, it can be said that it's a good idea to, do it by hand. How many people are just going to run home and try to do one of these by hand? Because why not? Okay. So anybody watching this video right now, and you would be stunned to know that every hand just went up in the room. Okay. And there's no way to disprove me. Okay. All right. Questions. How we doing? All right. Well, I'll tell you what. I've already got 202. I think we've got one more problem to do. So you don't have any homework per se. You got yourself quite a bit of time. Okay. What I want you to do. Okay. This next one here, remember where it shows you the calculator, that's for the 84. I already showed you how to do that. What I'd like for you to do, try at least one more by hand. Okay. It's not going to be horrible. Okay. It's not going to be horrible. Yeah, I know it's like when you say to somebody, no offense, but, I mean, it's pretty much guaranteed. Yeah, it's pretty much guaranteed you're about to offend the person.
You have to say no offense.
Yeah.
Something that's probably not something you should say.
Or if somebody likes to start, to be honest, they shouldn't have to say, I'm going to be honest. It should be true. Okay, so try this one, or at the very least, try it using technology and get a feel for it. Okay, so that when we come in on Monday, we'll wrap this up. We'll go ahead and continue with linear regression, our trend lines, and then hopefully probably by Tuesday or Wednesday, we'll be able to start chi-squared. Okay.